Welcome back. It's time to learn some more Python with Jordan and Jackie, except I'm sorry to tell you Jackie is not here today, so I'm afraid you're stuck with just Jordan. Okay, I think this one might be a little bit longer than some of our videos because we need to tackle a slightly more advanced concept, namely objects and classes in Python. So Python is what's called an object-oriented programming language. Most modern programming languages are, including C++, another well-known one. But so far, we haven't really gone much into the whole object-oriented thing, and it's a concept that can be quite confusing when you're new to it. So we're going to start with a very short little PowerPoint presentation here to illustrate some of the key concepts, and then I'm going to jump into showing you some examples to further illustrate the key concepts. So objects and classes. You can tell from the image here that I'm going to do this. Being a very good influence, I'm going to do this in the context of the casino game Blackjack. Just seemed a good example to use for this. All right, so normal variables we've done before. And let's imagine that we want to represent playing cards somehow in our program. We can do this using normal variables. So here are two sort of obvious ones that might feature. We've got card value, and we've got, is it a face card? Is face card. So in this case, we've got card value equals 9. So it's the 9 of something. Is face card equals false because the 9 is not one of the face cards. So those are the sort of lines of Python code that you might have to create, declare, initialize those variables. Over here, let's have a little look. We've kind of got three things for each of these. We've got the name of the variable, which is card value or is face card. Remember, I'm free to call those whatever I want, pretty much. Then, what type of data does this variable hold? Well, the first one is an integer, because it's a 9. It's a number with no decimal point. And the second one is a Boolean, true or false. And so when we create these variables, we are essentially creating a little box to store data in. Here's an illustration of our little box. We're giving it a unique name that we can later refer to it by to access that little box. And in the first one, the box holds the number 9. In the second one, the box holds the Boolean variable false. Okay, so this should be comfortable. We've done this kind of thing already. All right. Now, what is this whole objects and classes thing? So objects are basically another type of variable, a more complex type than the two examples on the previous slide. And classes are the type of variable that they are. So over here, we've got a variable called card value of type integer, a variable called isFaceCard of type Boolean. When we start doing object-oriented stuff, we are going to have an object of type a particular class. So let's use cards as an illustration of this. We might create a class for playing cards, right? So that's the generic option, just like Boolean is generic and integer is generic. So we're going to make a class that we're going to call playing card, and then we can create one or more instances of that class. So here we have an instance of an integer variable called card value. We have an instance of a Boolean variable called isFaceCard. I suppose we don't typically use the instance terminology for normal variables, but it's the same thing. Okay, so here we have an instance of a playing card class or type, and this particular one is the king of spades, so we call it king of spades. Okay, let's look a little bit further. So classes and objects, basically, the whole point of them, the reason they're useful, is that they allow us to group a whole bunch of data together into a single thing. And as we will see later, you can also group some sort of functionality. The terminology in this context is actually methods. But so as part of your class/object, you can have a whole bunch of data, and then you can also have like things you can do, levers you can pull, functions you can execute, methods you can execute. So in these illustrations here, we're for now just worrying about the data. So we have a card or playing card class that we'll see in a minute how to create in Python. And let's imagine that we want that card class to have 4 pieces of data, 4 variables. One of them is the suit of the card. One of them is the value of the card. One of them is the number of points that that card is worth in the game of blackjack. For anyone who doesn't know, in blackjack, the number cards are all worth a point, number of points equal to their number, but then all of the face cards, Jack, Queen, King, are worth 10 points, and the ace is worth either 1 or 11. Up to you. And then let's say we also want to have a Boolean saying, is it a face card? But now at the level of the class, we define these bits of data that we want associated with the class, these variables. They are, in this context, called instance variables. But they're empty initially, and we only actually put information in them when we create an instance of that class. So here which is an object. So here I'm illustrating the King of Spades object, where the suit instance variable is spades, the value instance variable is king, the points one is 10, and the is face is true, because the king is a face card, of course. So basically, the class defines the type of thing that we're dealing with, and then the object is one specific thing of that type. So not too bad, I hope, right? Yeah. Okay, let's see how we do this. So here I'm using Replit again. You've seen it in some of our earlier videos. And you're going to have to bear with me while I type this live. Okay, so let's see about creating our instance of a class. Now, the concepts that I just illustrated there are just the concepts. Fairly easy to wrap your head around, I think. As with everything programming related, when it comes time to actually implement this in Python, we have to worry about the specific syntax, the exact sort of stuff you have to type to get it to do what you want. All right, so when you are creating a class, the keyword for doing that is class. Unsurprising, huh? So I say I want to create a class, and now I need to give the name of the class, right? The name of the category, the name of the generic thing. And I'm going to call this playing card. And then just like with ifs and whiles and all of that, I use a colon to show that I'm sort of ending that line, and now the lines that come next are going to be the stuff inside that class definition. Okay, so let's press enter. Now, this is just one of those things you're kind of going to have to remember or ask ChatGPT later. I'm going to make a video about that as well. But inside the class here, we are going to define the functions or methods associated with the class. And there is one method that you always have to have. So we need to have a method that is going to be called behind the scenes whenever we create an instance of the class. So this is what you might call the constructor method, the method that is used to make this thing. The syntax is specific, kind of random, the sort of thing you might just need to look up if you're not doing this often enough to remember it. So we start by saying def because we are defining something. This is what you do with functions in general as well, even functions that aren't associated with classes. Now here's the rather specific syntax. We need to go underscore twice, then init, and then 2 more underscores. So that is just the slightly weird, obscure syntax for saying I am defining the initializer function or method. And unlike most methods, we don't actually give it our own name because we never call it by name. It's sort of done implicitly, as you will see in a second. Now, as with almost all functions and methods, we need some brackets for input parameters, and then we're going to have the semicolon, sorry, the colon that tells us we're going on to say what's inside this method. All right. Now, so in general, this is where we would pass information into a function or a method inside those brackets. And let's start with the more normal stuff. So when I am creating a new instance of a playing card type, I'm going to need to give it some information about its own properties. So I can't actually remember the order I had these on my PowerPoint slide, but we're going to want to give it the suit. We're going to want to give it the value. We're going to want to give it the points, and we're going to want to say, is it a face card? So this is now normal syntax that you would use for any other function, standalone function, or a class method. But when we are dealing with class methods, there's this weird thing we always have to do, which is that the first argument in the brackets here, the first thing we put in the brackets has to be the word self. Okay, so we'll see in a second how this is used. Basically, this is a way of letting it know which specific instance of the class we're dealing with. It's kind of like a placeholder that allows us to refer to my copy of the suit variable, my copy of the value variable, and so on. And what's a little bit weird about it is it has to be the first one. You have to include it inside the brackets along with any other arguments you want to pass. But as you'll see in a little bit, when we actually invoke these methods, when we use these methods, we don't actually have to say this. It kind of, we don't give it something in that slot. That just sort of comes automatically. What on earth are you talking about, Jordan? Well, hopefully it'll become clear in a minute. Okay, now inside the initializer method for our class is normally where we create the instance variables, where we create, let me just go back to the PowerPoint, these bits of data that we want our class to have and to store and to keep track of. Okay. And the way we refer inside the class definition, the way we refer to all of these instance variables, I may have accidentally said class variables at some point. That's a slightly different thing. Here we're dealing with instance variables. So the way we refer to them is by saying self dot and then the name. So here what I'm going to do is say self.suit is equal to suit. So the suit on its own here is this one, the input argument, which we're giving it a name here. We're using that name here. When we ultimately call this function, we just have to give some data in that slot. It doesn't have to have the same name. And so here we're saying my input argument suit, I'm going to store it in an internal instance variable that in this case I'm also calling suit, but this is my copy of suit, my one I'm going to remember. So self.suit equals suit, self.value equals value. What's going on? Sorry, guys. Self.points equals points, and self.isFace equals isFace. So I'm doing the same thing with all four of these bits of information that I'm going to pass in. I'm using the temporary holder that's created over here on the right-hand side of the equal sign, and I'm taking that and I'm putting it inside the instance variable self.suit, self.value, blah, blah, blah. Okay, so in this case, that is all I want or need inside the initializer function. Sorry, the initializer method. All right, now, you don't strictly need to have any other methods. Sometimes you might just want to have an object, well, a class/object as a way of holding bits of data together. So in fact, I guess let us do that. Let me show you that way of doing it first. All right, so I press enter. Now I'm back on the leftmost column here, which means I'm not indented at all, which means I'm no longer inside this definition method, and I'm also not inside the class. So now I'm just in the main part of my program. If this was a microcontroller program that I wanted to run over and over again, here is where I would have while true for my infinite loop, but in this case, I don't want that. Okay, so now I'm going to create an instance of the playing card class, and let's for now stick with the example King of Spades. So if I was to actually go further and build a program using these playing cards to, I don't know, simulate a game of blackjack, then I would maybe need to start doing something more fancy here. But for now, I'm just going to call the specific variable, this object variable, which is an instance of the playing card class. I'm going to call it king of spades. So that's just standard variable declaration stuff. And then I'm going to say king of spades is equal to a playing card. So here I'm using the name of the class. So I'm saying that king of spades is a thing of type playing card. And now I need to, so when I write this line, essentially, I know this is a little weird, but what I'm doing is calling this method over here. And so inside the brackets here, I need to give these 4 things. I don't need to give the self. It kind of just magically happens, knows that. So I need to give a suit, a value, the points, and whether it's a face card. So suit, we're going to say, is spades, which is a string. We've covered strings in a previous version. Value is king, which is also a string. The points of a king in blackjack is 10, so that's an integer. And is face is true because it's a face card. Okay, so this line is creating an object with the name king of spades of the type playing card, the class, and by writing this line, I am invoking the constructor method over here, and I am passing it all the input arguments at once except the first magical self thingamy. Okay, so now we have our king of spades, and let's run this. Cool. Nothing happens on the console because nothing here is outputting anything. Okay, but I have now created this variable of type playing card, and inside it has these 4 instance variables, each of which now contains a piece of information. So one of the ways that you can access information stored inside an object is by just directly referencing the instance variable. So what I could do is I could say print. Now, when we created it, it was self.suit, right? So oops, not pring. So say I want to print the suit. Now, you might think that I would go self.suit, but no, we don't, because the self terminology is only used inside the class definition. Here, what I need to do in place of self is use the name of the specific object, king of spades. So yeah, essentially what the whole self syntax inside the class definition does is it's just a way of saying whatever my name is, yeah, me.suit, me.value, and so on. Here, we know the specific one we're talking about, so it's print king of spades.suit, print king of spades dot value, print king of spades dot points, and print king of spades dot is face. Okay, now if we run this, we should see them all. Cool. Go away, please. Yeah. So spades, king, 10, true. These are just printing these 4 internal variables. Now, okay, in this particular case of playing cards, what I'm about to do here doesn't really make all that much sense, but I want to show you anyway. You can pull information out of the object's instance variables using this syntax, and you can also change the information in an object's instance variables that way. I mean, of course, it doesn't make sense for these values to change for a king of spades, but whatever. So we can say king of spades dot points. I don't know, maybe we're playing a different game now, some variant of blackjack. So let's say we want that to be 13 instead because it is the 13th card. And then if I print its value again, I'm just going to copy paste rather than type it again. Okay, let's try that. Oh, sorry, not value. I need to print points because that's the one that we changed. Let's try that again. Okay, cool. So here's the most recent output. So we're printing the original suit value points and whether it's face, spades, king, 10, true. Then this line is changing the value of one of those internal instance variables, from 10 to 13, and then we're printing it again, and we see that now it's 13. So in Python, this is typically the preferred way to pull information out. If you just want to get one of those variables out or change the value of one of them, then just doing it directly by referencing the name of the instance variable associated with the name of the particular object. That's the way to do it. But there are all sorts of situations in which we want additional methods associated with the class that allow us to do something in a more convenient way. Okay, so let's get rid of that. And let's now imagine that we want to, okay, so let's say we're going to have a whole bunch of different cards. So first things first, let us make another card down here. Type there, please. 6 of hearts is equal to a playing card. This one is suit hearts. This one's value is 6. Its points in blackjack is also 6, and it is not a face card. Right, so this is me just creating another object with a different name that is also of the type playing card, but which has different data stored in its internal instance variables. This is the whole thing that makes classes and objects useful, right? I could create any number of these, and I won't go into this in this particular lesson, but in fact, I could also create a list of objects, and then I could like index through them, and that way I could represent like the whole deck of 52 playing cards and stuff like that. Okay, so we've got our 6 of hearts, we've got our king of spades. Now, if I had just gone with printing the individual things like I did a moment ago, now I'd have to copy all of those lines for the other card that I want to show. So this is where it's useful to create a method to do some of these things for us. So we come back to our class definition. I've clicked over here, but I'm too far left. I'm not inside the class, so I need to do one tab. And I guess let's do it one line down. All right, so now I want to define another method. So define show card details. Okay. Now, so essentially the purpose of this method is going to be to just print out to the console the details of the card in question. You might think that that does not require any arguments inside the brackets, but it does, because every single class method that you ever create needs to have self as an input argument. Again, when I later call this, I'm not going to need to put self in the brackets. It's just this weird thing that happens behind the scenes. It's just one of those things you need to remember. You need the self. Okay, so we've got our colon. Now we go here and we do the stuff inside. All right, so let's print this in a slightly more sort of formatted way. So print, okay, let's go. This card is the, then a comma. So in a print statement, you can do any number of things separated by commas, and it'll just do them all together. Okay, so this card is the. Now we need to print self.value. So it's the king, the 6, the 2, the whatever. This card is the value of self.suit. Cool. And then let's say we're on another line. We want to say print which is worth self.points. Points. And we won't worry about the face thing for now. Okay, so I think that looks good. So when we call this, we're going to print out these messages with the values from the specific card in question. It's possible I've made a mistake. Let's see. Okay, so the way you call a method associated with your object, being an instance of your class, is you start with the name of the object. So king of spades. Then we use this dot syntax like we do with everything with objects really. Dot show card details. And then we need the empty brackets. You always need the brackets with methods and functions, but we don't have to pass it any information because the only input argument is self, and that comes for free. So king of spades does show card details, and then 6 of hearts dot show card details as well. Okay, cool. Let's see if that works. Ba-doink. And it would help if I maybe had a little bit more. So let's just run. Yeah. So this card is the king of spades, which is worth 10 points. And then this card is the 6 of hearts, which is worth 6 points. Cool. Okay. So, yeah. So you are free to create whatever methods, any number of methods for your class. In principle, I could create methods to specifically set the values. So I could make a method, and in some programming languages you need to or are encouraged to do this. In Python you can, but you don't need to, and it isn't really encouraged. But I can go def set value, and then I have to give it self, and I also have to say give it new value. Yeah, come on. And then I would here say self.value equals new value. So I could do that, which means down here I could then go 6 of hearts dot set value to 100. It's obviously stupid, but whatever. And then I could go 6 of hearts dot show card details. Yeah, looks good. Let's see what that does. Yep, cool. So it shows the 2 the first time. Then this set value method changes the value, and then we show it again, and now it's the 100 of hearts. Yeah, so one could do it this way, but really it makes much more sense. It's neater, it's more obvious. It's just generally better to just say that 6 of hearts dot value equals 100. Not waste time with that method over there. And you see that has exactly the same effect. It's just in a slightly more explicit and elegant way. Okay, so with my example of playing cards that I came up with this morning while I was preparing to shoot this video, this is kind of as far as I can go. This is probably as much as you want in one dose anyway. I see I'm at half an hour already, good grief. But really, I think, I hope that this illustrates sort of the basic structure of classes and objects, gives you some sense of why you would want to use them. Yeah. And if you need to know more, I mean, there's so much more cool stuff you can do with them, but I'm going to leave you to look that up in your own time. So that's all for this longer than average lesson. Hope you find it helpful, and I will see you in the next one. Bye for now.